back to my channel. Today we have domain of a function. By definition, when you talk of domain, you talk of the range of values to which a function is defined. The domain of a function is defined as the range of values to which a function is defined. We can use these few examples to absorb the definition to comprehend what domain of a function is all about. We can say given y is equal to x squared. You want to examine the domain of this function, the range of values that can be able to define this particular function. But before I continue, I would like to introduce to you guys the two parentheses we use in study of domain of a function. We have the one we call open interval and closed interval. So the parentheses, we call this the open interval. It's open interval. We call this the closed interval. So we use the open interval when we want to say that a particular number does not define the function. We use the open interval. Then when we want to say that a particular function, a particular number defines the function, we use the closed interval. For instance, when I have 0, infinity, this particular set, because I use open interval here, which is the type of parenthesis open interval here, it means that 0 does not define that particular function that has this as the domain. That's given that this is the domain of the function. The interpretation is all positive real numbers, not including 0. This parenthesis means 0 is not included. But if I have a domain of a function as 0 and infinity like this means all positive real numbers including 0, meaning that we use closed interval when we want to include, and we use open interval when we want to exclude. So exclusive is for open interval while inclusive is for closed interval. Okay. Now let's talk about find the domain. So we are interested to know the range of values that can define this function. Of course, 0 can define the function because when x is 0, x squared means 0 squared, which is 0. So, and all positive real numbers from 1, 2, 3, 4, 5 will define the function. When you start plugging in negative numbers to replace the value of x, minus 1, minus 2, minus 3, till negative infinity will define the function. So x equal to 0, when x is equal to 0, the function is defined because y will be equal to 0 squared, which is equal to 0. The function is defined when x is 0. And the function will also be defined when x is any number from 1 to infinity. And the function will also be defined as the value of y will be gotten at any values from minus 1 to minus infinity. Therefore, we can say that the domain of this function is all positive and negative real numbers including 0, because 0 also will define the function. Then how do I state it? Close open interval negative infinity 0 inclusive then 0 inclusive, and positive infinity. Then note, one thing you notice here is the infinity will always use the open interval to show the infinity, but the 0 it's not always, but whenever you want to cover your infinity, always use the open interval. So this means including 0, then from -1 to -infinity. This means including 0 and from +1 to positive infinity. Then connecting these two sets together, we have the total range of values to which this function could be defined. Therefore, this is the domain of the function. The interpretation means all positive and negative real numbers, also including 0, because of this parenthesis that I use close interval here, meaning 0 is inclusive. Then the next one I want us to talk about now is, let's examine the domain of this function 1 over x squared. The domain of this function 1 over x squared. Then when you check very well, you find out that 0 cannot define this function, because when x is equal to 0, the function tends to infinity. That function will give us indeterminate or undefined. The function will not be defined. Of course, you say that the domain of the function is the range of values to which the function could be defined. In this case, 0 cannot define the function, because when x is equal to 0, y will be equal to 1 over 0 squared, which is undefined. Meaning 0 cannot define the function. So we're going to use open interval with 0. So we can boldly say that the domain of the function is all positive and negative real numbers, not including 0, because when x is 1, definitely the function will be defined. When x is 2, till positive infinity, x is defined towards positive infinity. Then x is also defined from -1 towards negative infinity. The function is equally defined. So we can say that the domain of the function is all positive and negative real numbers, not including 0 or excluding 0. Then if you want to write it in set notation, we can say negative infinity excluding, this parenthesis means excluding 0, then excluding 0 to positive infinity, then unite. So this is the domain of this function, which is all positive and negative real numbers, not including 0, but from -1 to negative infinity, not including 0, and from 1 to positive infinity. So that's the domain of the function. Then the last one I would love to talk about now is y equal to sub x, that's square root of x. Let's examine the domain. Let's examine the domain of the function. Of course, when x is 0, when x is equal to 0, we have y to be equal to the square root of 0, which is equal to 0, meaning 0 can define the function. This is a perfect definition because 0 defines the function, but no negative number can define the function, because the square root of negative number is a complex number to reach the complex number. So if you check your calculator now, square root of -1 will give you math error. So you have to be in complex. The calculator must be in complex before it can be able to be computed. So just know that square root of any negative number is undefined. When x is -1, for instance, square root of -1 is undefined. Therefore, no negative number. There is no negative number that can be able to define this function. Therefore, the domain is from 0 to positive infinity. You get it? So we have the domain is all positive real numbers, including 0. So which will write this way, including 0 till infinity. That's 1 to infinity. That's the domain. Alright. The next thing we're going to talk about now is the codomain of a function. Codomain of a function. Okay, without wasting much time, codomain is the range of outputs. You can say output of a function is the codomain, while the inputs, range of inputs that defines a function is the domain, while the corresponding output is taken to be the codomain. So let's use one example to explain the domain. So let's say, given that f of x is equal to 3x squared plus 4x, 3x squared plus 4x, where the domain of the function, where the f is equal to 2, 3, 1. Find the codomain of the function. Solution. Of course, we've been provided with the input, which is the domain. We're asked to find the corresponding output, which is the codomain. So we have the function to be f of x equal to 3x squared plus 4x. And the first input is 2. Meaning we have f of 2, that's the value of function when x is 2. We have 2 squared plus 4 by 2. And of course, we have 3 by 4 plus 8. 3 by 4 is 12, and 12 plus 8 is 20. The second value is when x is 3. We have f of 3 is 3 times 3 squared plus 4 by 3, and of course 3 by 3 squared is 9 plus 12, and then of course we have 3 times 12 is 3 times 9 is 18, and 18 plus 12 is 30. Then the last is f of 1. To the same function when x is equal to 1, the value is 3 into 1 square plus 4 by 1, and that is 3 plus 4, which is equal to 7. Therefore, the codomain of the function f is equal to, the first answer is 20 by 30 by 7. Okay, that's about domain and codomain. Hope you enjoyed the video.